Hello everyone, and welcome to today's webinar hosted by the Cloud Standards Customer Council. Today we will discuss the CSCC's latest deliverable, which is a reference architecture for hosting big data and analytics on the cloud. We are joined by contributors Heather Kreger, Manav Gupta, and Statchuk to discuss the specific components of the architecture along with key considerations. Note that the paper is available today, and you can download a copy of the paper at the URL, which is on the bottom of this title slide here. We've also posted this white paper URL in a link to today's presentation in the chat box of the GoToWebinar toolbar, so you can access the paper from either place. This afternoon, we will post a recording of the webinar to the CSCC website, and I'll also send an email to everyone on the call tomorrow morning with a link to the presentation and recording. We should have some time at the end for Q&A. If you'd like to ask a question, you can use the questions box in the GoToWebinar toolbar. And with that brief introduction, I'll turn it over to you, Heather. Thanks.
Thank you so much. Can we go to the next slide? So this is our agenda today. So we're very excited to be here at the third in the series of Cloud Customer Architectures. The first two are listed down here. Today we're doing the big data and analytics and how to deploy that into cloud environments and the importance of using cloud with your big data analytics work in your environment. We'll also talk about open source projects and some scenarios. At the bottom here, we have the listings for all three of the architectures in this series. So we started with web application hosting cloud architecture, followed by the mobile cloud customer architecture for mobile, and today is the big data and analytics. So if we want to go to the next slide, thanks, Tracy. All right, so if you haven't been to the other two sessions and this is your first exposure to this work with big data analytics, let's just introduce what are cloud customer reference architectures and why are they important for us. So what are they? Well, they're just very straightforward descriptions of the elements needed to implement something in a particular application or a domain or a solution that you need for your business environment. And then how to actually deploy those into cloud infrastructure, cloud platforms, using cloud software, and cloud services. So it's sort of a 101 for that particular domain, followed by 102, how to use it with the cloud. These architectures are deployment neutral. You can deploy these capabilities in public, private, or hybrid environments. They're implementable using infrastructure as a service, platform as a service, or software as a service. There are general purpose and reusable architectures, these first three are, and we have a plan for some industry-specific architecture. So we are planning a whole series of very exciting work here. So why are they important to you and to us? Well, they're important because they get us all on the same page with the terminology and the concepts we're talking about and the relationship to cloud computing, so that you can understand all the caveats and interesting things to think about around a particular domain and its use in cloud computing, and then also be able to talk to cloud providers about these concepts and be talking apples to apples, so that you're both talking management and security in the same way. They provide some practical guidance on applying these in this particular domain or particular value for using cloud computing for these particular domains. They're useful when you're really starting your process of looking at cloud architectures for this particular domain. If you're planning these or you're just interested in learning and understanding, it does really provide this very foundational work with a simple architecture behind it. And we are targeting this towards architects, but also developers and managers as well who are interested in understanding. This is based on some existing international standards, so we think this will really resonate and help enable you to discuss with others. Next slide, please. So this is the whole series that we're talking about. So the first three here are today is big data analytics. We have mobile and web app hosting done, and we're hoping to do DevOps, hybrid security, hybrid integration, social, and there may be others there. But we're also looking at doing a set of industry-specific architectures, perhaps around e-commerce, financial, travel, healthcare, gaming, something around public sector. This is a very important set of architectures for governments in particular and telco. So if you're interested in participating or helping develop some of these architectures, or you have another industry that's not here on a list, or you have a very interesting general architecture that you want to put on the table, just give us a call, let us know, or send us an email, and we're happy to collaborate with you. Next slide. And with that, I'm going to turn it over to Manav Gupta and Statchuk, who were really some of the key authors on this work and key thinkers about this big data analytics reference architecture. So, Manav, take it away.
Okay, thank you, Heather. Good morning, good afternoon, everyone. My name is Manav Gupta, and I'll take you through the next few slides. So on the current slide, slide number 6, you have a bird's eye view of a big data and analytics solution within a cloud environment. So first of all, why would organizations do this? What we have found in working with clients around the world is when clients embark on an analytics or a big data and analytics solution, the upfront investment is quite high, whether it's to do with setting up the various data repositories, federating the data from existing and new data sources into those repositories, whether it's to do with establishing or extending existing information governance practices, as well as in certain cases, organizations may not know how valuable the analytics or the output is going to be based upon the current data set that they may be looking to process. So for some of these, for all of these reasons, cloud becomes a very critical adoption mechanism where it allows organizations to have low upfront commitment. They can do rapid experimentation and prototyping and assess whether the output is of value. And depending upon its perceived value, they can either continue down that path, change their analytics that they're doing, and as well as they can pay per use, pay by the drink as they go. So those are some of the critical reasons why organizations would want to do this. So on slide 6 here, at a bird's eye view, we have broken down the capabilities within a big data and analytics environment into 3 broad categories. So there are capabilities that exist in what we would broadly call as the public network, and these may be data sources. So the public network here is anything that exists outside of the enterprise network. Theoretically, you could argue that the user may be within the enterprise network as well, but equally, given the nature of cloud computing and network everywhere as one of the fundamental tenets of cloud, the users can access services on the cloud with the right credentials literally from anywhere in the world. Hence, the user resides in the public network. The data sources within the public network, and we'll delve into those a bit more detail, may also exist outside of the network, outside of the enterprise network as well. Moving on to the rectangle in the middle in the provider cloud, there are a whole host of capabilities that the cloud providers will provide in order to provide an end-to-end analytics solution. And these capabilities range from capabilities for integration of data sources to the data repositories to applications that provide actionable insight and a few others. And then moving over to the far right to the enterprise network, that depicts the typical capabilities and resources that would remain within an enterprise. These may be legacy enterprise systems such as the enterprise user directory, or data that's core to the enterprise's operations such as their reference data, master data, and other business critical enterprise applications. So at a bird's eye view, that's how we would depict it. Next slide, please. So slide 7 now is the connectivity between the various components. So it's the same diagram. I'm sorry, was that a question? Okay. So slide 7 is the same view as before, but with the connectivity between the various components. The idea here is that starting from data sources on the bottom left, there would be edge services provided by the cloud provider. Some of these edge services you are already familiar with from the previous architecture, such as the mobile reference architecture, which are leveraged by the cloud provider to provide capabilities of integrating those data sources into the big data and analytics capabilities that the cloud provider provides. And then once the data is integrated into the big data and analytics capabilities, there is further downstream flow that the cloud provider provides in order for organizations to actually obtain some value. So what we'll then now do subsequently is delve into the capabilities for each of those components. So moving on to slide 8, please. So let's start with the data sources. So in any analytics solution today, there are a large number of data sources which we would call traditional data sources that exist. Now, historically, organizations have always had, whether it's telco industries or the financial industry, even utilities, or any other industry for that matter, they've always had a vast variety of data. However, the technology of the day hasn't been robust enough to allow them to process all of that data. So what has happened in the past is organizations would spend a lot of time, or the data scientists would spend a lot of time curating the data before it is processed. So the idea was to spend a lot of time investigating what type of data sources would make sense, whether that data would be of value, shape that data into whether it's the third normal form, if you were to follow E.F. Scott's theorems as an example, before it gets ingested into relational databases. But with the emergence of big data and analytics capabilities, those technological limitations are no longer there. You now have capabilities, as I'm sure everybody on the call already knows, to be able to process significantly large volumes and velocities of data than before. So when we now talk about the data sources, they range from the traditional data sources such as your transactional data or data that's of high value to the organizations, to new sources of data that may or may not exist within the enterprise. So the new sources of data range from structured data such as metadata about transactions to unstructured sources of information such as machine and sensor data or image data, video data, as well as now more and more organizations are looking to augment the value of the data and add context to the data based upon social media data such as data from Twitter, Facebook, blogosphere, and so on. And then finally, as the applications of today are enriched and made available for integration with third parties or extending to third parties, data from business partners and other sources of data such as open data sources that are made available by third parties, those would be leveraged as well. So when we talk about data sources in this scenario, we are talking about all of these data sources. Next slide, please. So slide 9 here talks about the edge services. Again, you may have seen these edge services already before. These span from the domain name systems allowing the data sources to talk to the services made available by the cloud provider, the CDN or the content delivery networks that ensures that there is sufficient bandwidth available for adequate transfer of data, firewalls and load balancer capabilities so that the applications provided by the cloud provider can scale rapidly and scale in a logical manner. Slide 10, please. Right, so the first capability within a big data and analytics solution architecture provided by the cloud provider of interest is the real-time analytics engine or the streaming computing component. It typically has two key components to it. There is a real-time processing capability as well as a data augmentation capability. The real-time engine here speaks to the capability to ingest continuous streams of data. So let's take an example. In the financial world, you have stock data or the stock ticker, which gets updated pretty much as a continuous data stream. Or if you work with the telecom industry, you have call detail records or other types of network data that keeps being generated by the machines in a continuous fashion. So you need an engine that can continuously ingest data and in certain cases provide you instant analytics, near real-time analytics at the speed of the wire as the data is being read. And those might be fairly sophisticated analytics at that. So the real-time analytical processing engine provides the capability to ingest data as it's produced, as well as provide you analytics. So again, going back to the telco example, the real-time example might be, so every time you dial a number and hit call, behind the scenes, your telco operator is deciding whether or not you're even eligible to make that call, as a simple example. In a financial industry example, every time you swipe your credit card or your debit card, there are fraud systems, as an example, that are processing the metadata in the background to classify whether this transaction is fraudulent or whether this transaction can be allowed to go. The data augmentation capability here talks to the ability to interface with enrichment data or lookup data that can be used to augment the analytics that's actually being run by the real-time engine. And this might be this typically requires a very fast, low latency database that can be used by the real-time engine. So as you can imagine, in the financial industry example, the end users such as you and I are not going to be terribly happy if we have to wait several minutes or more than a few seconds for our transactions to go through. So what the real-time analytics engine requires is a very high-speed, low-latency database that can be used to enrich the data, whether it's for information such as, last time this particular user made a transaction 5 minutes ago in location A. 5 minutes later, the same person cannot make a transaction 5,000 kilometers apart. So when we talk about the streaming computing, those are the two key critical capabilities. Next slide, please. Moving to the data integration capabilities, this speaks to the capabilities required for staging the data, loading the data into the data repositories, as well as capabilities for doing any transformation to the data. Now, one of the key things to note here is that not all of these capabilities may be required for every solution. So you may have scenarios that because of the sheer volume of the data, you may not need to, or you may not wish to do any transformation upfront, in which case, rather than doing ETL, you are doing ELT. So you're loading all of the data into the data repositories. The data quality component here speaks to the type of quality checks, sanity checks, or establishment of data veracity that's being done before the data gets ingested into the data repositories. And you may wish to do this for a wide variety of reasons. Typically, in today's world, when you're integrating your analytics solutions with third-party or internet data, you really cannot trust the veracity of the data. So long as the data generated from within the organization's boundaries, you still know what the data was. And you might be doing quality checks to ensure that there are no null values, as an example, or that the boundary conditions for a given variable that you expect the actual data meets those boundary conditions. So when we talk about data quality, that's the type of checks that are being performed on the data. The data staging capability here speaks to either providing you a subset of the data that's being loaded into the data warehouse, or providing a view into the data that exists in the data repositories. So let's take an example. Let's say you have a multi-petabyte data in your data cluster, and your data scientists would like to run, or your line of business unit would like to run a report on the most fraudulent transactions, or the transactions that have the highest indicators of fraud in a given geography. At that point, into that multi-petabyte data repository, you require insight or a window into a small portion of the data. So data staging capabilities allow you to talk to your data repository, potentially extract a portion of the data, stage that data in a temporary location for you, and then allow your data scientists, analysts, line of business users, and others to potentially run reports on that. Next slide, please. Right. So I talked about the data repositories a few times. What we have seen over the course of last few years is a large number of different types of these data repositories emerging. Starting at the very top, data warehousing, or the enterprise data warehouses, which is a typical data warehouses that I would imagine most people are familiar with. The landing, exploration, or the archive zone is also typically one of the key use cases for Hadoop, which emerged out of Google's paper on MapReduce in 2006. which really allows you to store both structured and unstructured information cheaply over commodity hardware that's scaled horizontally in a non-linear, approximately linear fashion. And due to its nature of keeping multiple copies of the data by default, you may wish to use that as an archive for your data as well. In some organizations, that may form the basis for your, or at least a portion of your data lake or your data reservoir. The deep analytics and modeling zone, or the deep analytics and modeling repository, speaks to the analytics star schema-based type of data warehouses that allow you to do multi-dimensional analytics. That's where the specialized analytics appliances may come into play as well. The interactive analysis and reporting speaks to capabilities provided by the likes of Apache Spark as an example that allow you to have real-time interactive analytics on multi-petabyte sized data repositories. So in the past, some of these capabilities were also made available by the likes of Google Tremel, or in the case of IBM, via the use of our big sheets, which allow you to have a SQL, which allow you to have an Excel spreadsheet-based interface to the data that's sitting in your data repository, that your data repository may or may not be Hadoop in that case. But it's allowing you a window into your data repository in a column format as an example, and allows you to interplay with your data fairly rapidly. And then finally, the key capability that makes all of these data warehouses as well as the data staging capabilities possible is the catalog. The catalog allows you a window into the type of data you have, whether it's structured or unstructured, and allows you to build the actual views into the data. So when we talk about these data repositories, what we are talking about is you will choose, or depending upon your requirement, you will choose one or more of these repositories that the cloud provider will provide, and you'll choose those to suit your business needs. So as an example, if there is an organization that's looking to store large amounts of call detail records, so let's say you are in the telecom industry and your client is looking to do analytics on their call detail records, and typically they will use this analytics to establish behavioral patterns. So one of the examples being that you're looking to find out that the client is looking to find out whether a certain user is a daily commuter. So does their cell phone talk to certain towers in the morning, certain cell towers in the evening, so then they can establish behavioral patterns that you're a daily plotter. And the reason they would do this then is once they know what their user pattern looks like within a certain area, then they can route their techs to do the updates to the cell towers as an example. They may even use that data to partner with third parties to sell additional value-added coupons as an example. Sometimes they may use this for their own planning purposes, that if there are some upcoming events coming in, so they might be interfacing with governments to ensure that if there is some outage or some work that needs to be done, they can plan it adequately. So in that type of a scenario, maybe your use case requires that you simply need a Hadoop or a landing zone, a landing exploration and archive zone, and you may not need a deep analytics zone for that use case. So the point I'm trying to make here is the cloud providers will provide you many different types of these repositories, and you got to pick the one that makes sense for you, for your requirements. Next slide, please. Moving on to Actionable Insight, these are, again, optional, yet very necessary, very important applications, are typically SaaS type of applications that the cloud providers may provide. The idea here is that while organizations may have a number of these capabilities on-prem themselves, in a lot of cases, rather than building these from scratch, most of these tend to be COTS applications anyway. So if these are COTS applications, cloud providers will typically make these available on the cloud itself. So the idea there then is that since they're sitting pretty close to the data sources, the capability to extract a portion of the data and use that data to do an actionable insight or an action is going to be quite high. So running down the list of the type of these applications, and this is not an exhaustive list, but this is the most common list. So 80 to 90% of the in 80 to 90% of the cases, these applications cover most of the applications. So these run from things such as our decision management systems. So whether these are operational or analytics decision management systems. So as an example, in the for a call center agent, when you have millions of calls coming in every day, they may sometimes have irate customers calling, and then depending upon customer's profile, customer's background, and the severity and the longevity of the issues that they have faced, the operational decision management system may make some decisions based upon some business rules and allow the operator to produce a next best action. Now, whether that may be an action in terms of offering them a coupon or offering the client some other incentive to mollify the client and to resolve the situation. The analytics decision management systems are more analytics-driven systems that may be used for intelligent decision making. So an example here is these analytics decision management systems sometimes make use of analytics to decide when to schedule maintenance, when to turn systems up and down, as an example. The discovery and the exploration capabilities here speak to applications that allow you to find, or applications that will typically allow the data scientists to find hitherto unknown patterns and explore data as the data is being landed, So again, when I previously talked about the catalog in the data repositories, the discovery and the exploration applications will talk to the catalog and then provide a window into the incoming data to the data scientists. The predictive analytics applications span a wide variety of applications, and these will run from things such as applications for predictive maintenance, applications that will provide predictive insight into impending outages. So fundamentally, what these applications are doing is they are establishing an understanding of the trends on the data, or at least on the subset of the data, and then providing a forecast for when a boundary condition is going to be exceeded. So that's what the predictive analytics applications provide. The analysis and the reporting capabilities are your typical BI, business intelligence type of reports, personified by the Tableau software of this world, or IBM's equivalent Cognos as an example. The content analysis applications typically provide you text-based searches and allow you to perform text-based queries to identify patterns based upon text, even the unstructured data sources. The planning and forecasting applications are typically used for financial planning and forecasting for where to spend or making intelligent decisions around, as an example, the fluctuations in equity markets, risks to credit scores, whether or not a certain customer qualifies for a loan to be given out, etc. So that's the complete list of the Actionable Insight applications. Next slide, please. The transformation and connectivity layer, and you may have seen some of these capabilities already in the mobile reference architecture. These span things such as secure connectivity between the cloud provider and the enterprise network. In case of IBM, as an example, we'll provide this over a private secure gateway, which essentially is a secure VPN tunnel that gets established between the cloud provider, whether it's IBM's own cloud, and the enterprise network. The transformations capabilities speak to any further transformations that are required for the data sitting in the data repositories or in the Actionable Insight applications to be converted for use by the enterprise applications. The enterprise data connectivity speaks to any SaaS type of capabilities available to map the data formats from one source to another. And then finally, what we see here is API management capabilities being made available. So previously, I spoke about enterprises using these type of models to monetize their data or make their data available to third parties. One of the very common and emerging use cases that we see is organizations using the plethora of data that they have and to try and monetize that. And the most common use case there is that organizations will create new APIs, but then they need a mechanism to track, well, first of all, to expose those APIs to their business users, and then track the usage of those APIs and meter those APIs. So the API management capability here speaks to the last three. The idea here is that a consumer, an enterprise user, or an enterprise using these capabilities from the cloud provider will not only use these data integration or the data repositories and others, they will use these to create new APIs, publish those APIs to their partner ecosystem, and then use the API management capabilities to track their usage, which then allows them a very simple, scalable, and a meaningful way to monetize their data. Next slide, please. Within the enterprise network, here's a brief list of the type of enterprise applications that would be consuming the data. These span your typical customer experience applications, whether the customers are happy or not, or the applications that are helping the organizations generate new business models, whether it's in terms of making new offers or being able to monitor the data, as an example, as a new business model. You may have applications here measuring the financial performance of the organization, or calculating risk, whether it's risk to the organization's own business or risk based upon the data sets they have seen. Applications that help organizations make decisions about IT economics, whether a certain program makes sense for continued investment or should they sunset that. And then finally, your traditional existing operations and fraud type of applications, whether it's typical applications to improve operations of the organization or for improved fraud detection. Next slide, please. Okay, so finally, the enterprise data. So that's the, I'd spoken earlier about some portions of the data still residing within the enterprise boundaries. Here's an exhaustive list of the type of repositories an organization would still decide to keep within their boundaries. These include things such as reference data, which may be actually updated as data from new sources is being ingested and stored into the data repositories. The master data might actually be used as a source of reference to improve and augment the analytics. Other sources of data here are things such as transactional data, whether it's and the transaction here speaks to any type of business transactions that are critical for that business. And then finally, you may have other things such as the application data, the log data, the historical data related to the records that are being processed in that environment. Next slide, please. So I talked about the enterprise data. Another critical component that will continue to sit within the enterprise network is the enterprise user directory. So things such as the enterprise LDAP that has authentication and authorization capabilities, so that when the users do log in and use the resulting application and the analytics, and these may be users not just within the boundaries of the enterprise, but users such as the business partners. So they will be authenticated against the enterprise's LDAP for establishing veracity, whether these users are actually allowed to access this data and analytics or not. Next slide, please. So you may have seen by now these two rectangles at the bottom are up for security and information governance. The idea here is that these two tenets will span the entire portfolio, will span the entire solution. So when we talk about security, there is obviously the actual physical security as well as the identity and access management capabilities that the cloud provider will provide, such that not only is it authentication just direct, to the capabilities provided by the cloud provider, but that authentication would be federated against the enterprise user directory. Further, there will be additional layers of security provided, such as the application and data protection, and that may be done in the form of passive probes being run by the cloud provider to ensure that their systems are robust and secure enough, as well as they may provide other layers of security using tools such as security intelligence. So they're basically collecting security information from each of the capabilities sitting within the cloud provider environment, and to ensure that there are no single points of failure and there are no vulnerabilities. Next slide, please. Sorry, can I get the next slide? So it's not updating for some reason, but on the next slide we talk about information governance. There we go. Information governance in this context speaks to the policies as well as the capabilities that enables the analytics environment to move, manage, and govern the data. These the information governance will typically be a practice within the organization that governs the full life cycle of the data. So how the data would be ingested, how it's going to be stored, and by how I don't mean the physical aspects of that, but as to how long you're going to be storing that data. Who has capability to access the data? What type of analytics you're going to be making available for either users within the enterprise or the business partners to use? How long you're going to allow them access, and what type of analytics or what type of anonymizing capabilities you would do on that analytics so that third parties cannot misuse the data that you have. And then finally, how would you dispose of that data? So that practice will exist within the enterprise as it does today, and it may require further investment by the organization to ensure that when any organization embarks on using big data and analytics solutions under the cloud, there is no scope for misuse. Next slide, please. So I hope by now you have a good overview of all of the capabilities within the big data analytics solution within a cloud environment. And then slide 21 provides you a bird's eye view of, okay. So I missed one slide, which is to do with the cloud user. The cloud user will typically remain, well, can be depicted either in the enterprise network or in the public domain. The cloud user will typically have self-service capabilities made available or made possible due to the delivery model of the cloud. So typically all of these capabilities will be made available via a self-service portal. The user can go in, use services made available by the cloud provider. The user will also have some capabilities to visualize the data, whether it's visualization components within the data repositories or the Actionable Insight applications, as well as there may be visualizations at other layers such as the data integration capabilities themselves as well. Finally, slide 21 provides a platform as a service view. So the emerging PaaS, application PaaS environments such as Bluemix from IBM or Cloud Foundry from Pivotal, these type of systems typically will have all of the capabilities within this big circle made available as services. So so as an end user, you will have an account created with these PaaS providers, and you can pay for these services by the drink, and you can, and how you integrate with that, how you govern the data flow is made possible for you by you based upon the services that the PaaS provider provides. So moving on to slide 22, you get all of the details of the various components of the architecture. So I'll pause there on 22, and I'll hand it over to my colleague Craig to take you to the next 2 slides.
Hello, and thank you, Manav. Hey, a lot of information there. 3 things I want to emphasize. Why we're using cloud is time to value, the ability to provide continuous delivery of software, and the best programmer I ever met 20 years ago started a large BI company. He said, the developers who iterate the most win. And this is the environment where we can do that. So today I want to present to you, next slide please. We want to get up to the intro slide for what we're going to talk about. I want to present to you a cloud system for managing fraud and identity theft using all the components that Manav has talked about. So next slide please. So we start with a system that allows end users, business users, and third parties to gain access to the system. We control the ability to go after different resources with an access control component, and its main job is to provide security and transparent access to the resources on the other side. 500,000 laptops are stolen every year from airports through either leaving them behind or whatever. And the idea here is that a centralized system can provide better security, but it's got to do it by making sure that access control works. So that's our primary goal. Next slide, please. So a system like a finance system, a fraud system, what it's going to do is bring in new types of sources, government, social media, demographics. They'll all be brought into the system through the edge services. And remember, the ability to iterate is key. So they're brought into a staging area so that we can reuse that information and go over it hundreds of millions of times. Next slide, please. The requirement is that we need to verify and normalize, but not so good that it becomes the data marts that we used to be familiar with. The idea is to make it just good enough, just normalized enough so you can answer lots of questions across a wide domain of information. In the fraud business, the idea is to align it as much as possible, remove inconsistencies, and get the data ready for analytics, which really means wide tables with lots and lots of data. Next, please. Now, time matters. 5% of credit card transactions are fraudulent in terms of value, and 9 million identities are stolen every year in the U.S. The fraud industry knows the best way to stop this abuse is to curtail it on the first transaction. So the ability to capture a fraudulent activity based on analytics is a real way to save money and reduce risk. All right, next slide, please. Now, real-time makes great TV, but at the end of the day, it's the analytics that we do in the back office that provide value. 2 things are very important to the fraud industry: predictive, which is taking what you know to predict into the future, and entity analytics, the ability to take all the different aliases that we have on the web and turn it into an identifier for one person. So for this kind of application, the idea is to align transactions and data to either people, accounts, or location so that we can do better analytics, better slicing and dicing of the data. Next slide, please. With data aligned, the analysts can now get their hands dirty. They can go in, they can start to look for outliers, find abnormal activity. That's great, but the idea is that you have to pick your battles. So with the data better aligned, it becomes easier to pick the data sets and find the outliers so you can do deeper analytics. And that's really what we're looking for, looking to make the data more valuable and therefore create the insight that we can share to the stakeholders of the system. Next slide, please. So operational data still matters. We still run our business from the data marts that have run business for the last 30 years, but now we have the ability to augment it with this new information, and through the ability to transform and deliver, we can combine and give you aggregate applications that give you both the system of record and now the new systems of engagement that show how the data sticks together on information that is newer and faster that you never had before. The whole value of cloud through this whole chain, the reason we've talked about all this is that you are getting data in days, not months and not years. All right? So things that happened 2 months ago just don't matter anymore. We want the data that happened today to be delivered to our end users, to our enterprise applications as fast as we can. All right, next slide, please. And the final point worth mentioning, you know, we used to sell systems that were the single version of the truth. We're now trying to sell the best supported version of the truth. And that means the ability to present a cohesive and compelling result to the stakeholders. And that's ultimately what we have done with this kind of system. The finance, the fraud systems that we built using this architecture, that's where they've delivered their value. All right, so next slide, please. So as we look across all the different technologies we've talked about today, we want to do a quick mapping to open source. I was talking to a client last week, and they said, "No, how do you buy software?" And he said, "You know, we do try, prove, and then scale." So the idea is you have a component you want to try out, you make sure that it works for your application, and then you worry about scaling down the road. All fits into this iterative, quick time to value system, and you know, open source is part of that equation for every customer. So next slide, please. First place we bring in new components is what we last talked about, platform as a cloud. That's Cloud Foundry, OpenShift are both open source providers who give us the infrastructure to build the rest of the systems. Next slide, please. On top of that, to protect our resources, to give us an access to the system, we've all used the Apache web server, OpenStack Object Store, very good ways of providing a space to your customers, keeping the resources inside your enterprise safe. Next, please. In the real-time side, we've talked about some of that. Apache Storm, Pulsar, and Tgon are all applications that can provide real-time streaming. Next, please. Here's a good quote from one of the competitors that we have, Tableau. They say that 80% of the time you spend preparing your data to get it ready for reporting. It's funny because they're in the business of providing quick data, and yet they recognize that preparing data is a huge investment. So in the terms of refinement and data precision, two key players there, Paxata, OpenRefine, which used to be Google Refine, very good places to start to get your data aligned. Next, please. And then producing the data that we need, we have both Spark and Hadoop. All right, Spark getting great momentum these days, along with the file systems that I think we're all familiar with. Next, please. We're going to make the time limit, guys. Transform, connect, getting that data to the end user, to the applications. We have both ActiveMQ, Tick, and MobaSense. One more, please. Next. OpenLDAP, everybody uses that. OpenStack Keystone, and the NoSQL databases, which are augmented by the SQL databases that we're familiar with. Very powerful, part of every application. And let's finish with the good stuff. Next, please. And then this is where we provide the actual insight, and I think this is where a lot of the really fun stuff is happening. So we have open source reporting from BERT and Pitaho as examples. Mahout provides machine learning and the ability to deal with data on given an example, let it learn from that example. Jupyter, very popular with data scientists to bring new data into things like Python, get it processed and to the end user in minutes, not even days. R, our favorite open source for doing statistics. D3, the best way to do 2D graphics on a web browser. And finally, scikit-learn, probably the largest repository of open source statistics anywhere in the world, all very good. So I hope this presentation has given you guys a feeling for what we can do together with open source, the things that matter, and thank you very much for listening. I'm going to hand it back to Heather, and she's going to wrap up for us. So thanks very much.
Thank you very much, Craig. That's very exciting stuff. Let's just go on to the next slide real quick. So just a call to action. That's the end of our presentation today. So come join us in the CSCC. Please come participate in the work that we have going on around these architectures. This is going to be very exciting here in the next 6 months. And here's some links to the architectures so that you can go download the papers and have a look. And there are webinars available here on the CSCC for those different architectures, including this one will also be available at the CSCC site. The next slide has a set of cloud resources, additional resources if you're interested in other information available from the CSCC. And now we have a few minutes for questions.
Thanks, Heather. It's Tracy from the CSCC. And thank you also, Craig and Manav. We do have a couple questions. Let me pull those up. It looks like we're doing pretty good for time, about 6 minutes. First question, can you explain some streaming technologies used in industry?
Sorry, Tracy, can you repeat the question?
Yeah, the question is, can you explain some streaming technologies used in industry?
So the two most common ones that I personally know of is either the Storm capabilities in the Apache Storm project or the InfoSphere Streams capabilities that IBM has. Those are the two that I come across quite frequently. They have slightly different architectural approaches. In Streams, as an example, one of the key things that it does, it allows you to create operators to perform certain type of operations, and the intent is you can then reuse those operators repeatedly to build complex applications that again get scored in real time. Storm also has a slightly different way of doing things. Essentially, the idea is both Storm and Streams will attempt to be almost linearly scalable, even though as the ingest data velocity and the volume of data will increase. So in a quick summary, that's how I would summarize it. If there is more information required, I guess we can either point to some links on the IBM.com website, or you can Google Apache Storm.
Great. That person says thank you for answering. Another question, a strong relationship is required between the cloud provider and the enterprise to effectively deploy this architecture. Should customers leverage their service level agreement with the cloud provider as a way to document specific requirements? And could you give a couple of examples of the type of requirements that could be included or should be included?
I think that's a great question. So allow me to make a provocative statement first of all and say, at least when you're starting out and you're trialing out, experimenting, and building new applications, you may not necessarily need to spend an awful lot of time documenting those SLAs. And the reason why I say that is most cloud providers generally have very good availability on their services with documented SLAs for the individual components. That said, in a true enterprise scenario, when you are building something that's critical in providing you useful, meaningful data and meaningful analytics to the organization, you obviously would require more meaningful SLAs. Typically, the SLAs in this space would be around data retention and data protection, so making sure that if you would like to store the data, it doesn't get lost. So there are reasonable backup and snapshotting type of capabilities available by the cloud provider, whether they are doing the deduplicate, whether they're creating multiple copies of data themselves, as an example. If you are using streaming computing, then your typical your typical SLAs would be around the velocity of the data that you're expecting, and that will generally define a new set of SLAs to be created. And in general, if you are using the Actionable Insight applications, you may have some SLAs around around the availability of those applications. So broadly speaking, that's the type of SLAs you would see.
And I can add that, this ties into the try, prove, and scale methodology used by one of our customers. And it really says you can try it out on cloud and get feedback to figure out what your actual SLA has to be. So you're actually doing the sort of agile thing, which is creating a burn down, which represents your actual usage, and then you can do a much better job of predicting what you are going to use.
Great, thank you. Let's see. This may be our last question here. Are there instances when actionable insight is performed within the enterprise, for example, where there may be sensitive data that the enterprise does not want to entrust to the cloud provider?
Yeah. Yep. Hey, let me take that one. Okay. So the idea, this really comes up in two ways. There is a desire to secure certain data, particularly the output of the analytics that they're talking about there, because you can create some very secure and otherwise sensitive information that you don't want shared. So they do that, and there's also a sort of geospatial aspect where there are jurisdictions which will say you can't store this information in different places. So this is a prime motivator for hybrid cloud. The ability to use this cloud architecture, use the PaaS as a service that we're talking about, but bring the key elements that around security and bring them in-house and keep them on-premise. So look for that, and don't be afraid to ask for those standards when you have secure data that you don't want shared anywhere else. That's perfectly viable and perfectly acceptable in a cloud environment nowadays.
Great. Just sharing a presentation. Thank you. Yeah, I just want to remind everyone we've had a few requests come in for a copy of today's presentation slides, so I will send a note to the couple of people that just asked about it in the questions box. Also, tomorrow morning we'll send a direct link to the recording and presentation. They'll be up on the CSCC site this afternoon. If you want to check, if you go to our events page, it should be the first event listing there. We'll have a link to the white paper, a link to the recording, which goes to YouTube, and also a link to the slide deck from today. But for the couple of people that asked, I'll send you a note separately right after this. So thank you, everyone, for your time today. And again, you're invited to join the CSCC. Membership is free, and our site is cloud-council.org. And there you can consider joining a working group if you'd like to participate in deliverables such as this new white paper. And we'd also like to invite you to future events. So thank you, everyone, and have a great day. Bye.
Thanks, Tracy. Thanks, everyone.